is the first lesson in our unit on exponents. And we're going to start out with a few easy ones to get us started here. Number 1, 5 squared. Remember, that does not mean 5 times 2. It means 5 times 5. 5 times 5 would be 25. Good. Okay. On we go to number 2. 3 squared would be 9. Number 3, 7 squared? 49. 49, good. And this is a no calculator unit. We are not using calculators on this unit. Okay. Number 4, we did discuss the difference here between problems like 4 and problems like 5 earlier in the year. If the negative is in parentheses, that means you are also squaring the negative. So number 4 is a negative 3 times a negative 3, which is a positive 9. Very good. So if it's helpful, maybe you should make a little note that this means negative 3 times negative 3, just so when you go back to your notes you have that. The difference is now in number 5, this really just means a negative 6 times 6. The 6 is the only number being squared. So 6 times 6 is 36, and then because of the negative, it's a negative 36. Okay, so you've got to keep those situated. Okay, number 6, negative 8 in parentheses squared would be what? 64. Positive 64. Very good. Number 7, negative 8 squared, no parentheses, would be what? Negative 64. Okay, good. Number 8, 2 to the third power, 2 or 2 cubed. 2 times 2 times 2 is 8. Very good. Number 9, negative 3 in parentheses to the third power is going to mean negative 3 times negative 3 times negative 3. What would that be?
Negative 27.
Negative 27. Very good. Okay. Number 10 is a negative 3 times 3 times 3. What would that be? That one ends up being negative 27 as well, because it's an odd number of negatives in number 9. So you end up getting the same thing. Okay, number 11, 4 to the third power. 4 times 4 is 16. 16 times 4, if you don't know it, figure it out to the side. 64. Very good. Okay, number 12. Anything, whether it's an integer or a variable or a monkey in parentheses or anything to the 0 power is always 1. That is one of our rules. Anything to the 0 power is always 1. It's always 1, okay? That's a 1, sorry. So you might want to make a little note somewhere that any number to the 0 power equals 1. I wrote it over on the board. I don't really have room to write on this lesson, so if you're listening to the lesson, feel free to write down that one of our rules for today is any number to the 0 power equals 1. So now look at 13. 258 to the 0 power. What's the answer going to be?
1.
1, exactly. Okay, number 14. X to the 0 power
1
is 1. Okay, all right. Number 15. Now we're back to some that we should be able to figure out. 2 squared is 4 times 3 squared is 9, and 4 times 9 is 36. Very good. Okay, number 16. 5 squared is 25 times 2 to the third power. 2 times 2 times 2. 8. And 25 times 8 is 200. Number 17. 6 squared is 36 times 2 squared is 4. And 36 times 4 is 144. Double check me on that.
It's 144.
Okay, good. All right, now, this is where we get into some of the new rules, so you really want to pay attention, okay? If we do not have an exponent, just like if we do not have a coefficient, the coefficients are 1. We know that, right? We should know that by now. Okay? Same thing with the exponents. If you don't see an exponent, it is a power of 1. Okay? So, what you want to do first is you want to multiply all of the coefficients first. So all the coefficients, 1 times 1 times 1 times 1 times 1 times, in this case, because they're all ones, you don't need to worry about it, okay? But if they were other numbers, you would need to multiply. So we just have 1, which we don't need to put. And then y to the, add them up, yes, 6th power. Okay, and that's another rule now. That's the second rule that I have over here on the board that you should write down, which says, when multiplying with the same base, add the exponents. Okay, now same base, meaning the y is the base here. Okay, the difference between a base and an exponent, for example, the base is this larger number or variable, and the exponent is the little bitty one that's raised up to the right. Okay, so they have to be the same base in order to add the exponents. So let's look at 19. All right, so we don't have any, the coefficients are just 1, so we don't need to worry about that. They're all the same base, so it's going to be x to the third power. Very good. Okay, now, number 20, we have coefficients here. We have 3, and you know what I noticed is sometimes it's easier to explain it this way. You know that 3x means 3 times x, right? Yes. Okay, times 3 times x times 3 times x times 3 times x. So really, it's just a bunch of multiplication here. So you can't just look at that as just being a 3. It's 3 times 3 times 3 times 3, which would be what? 81. So you multiply the coefficients, and then you're going to add the exponents that all have the same base. So we only have x, so x to the fourth power. 81, x to the 4th power. That is the answer. 81x to the 4th. That's as simplified as you can get there. Okay, let's look at 21. So now we have a -5. That's the coefficient. Take care of the coefficient first. -5 times -5 is a positive 25 times a -5, a negative 125. Okay, and then what? Z
to the third power.
To the third power. Because remember, we got z to the first, z to the first, z to the first. And if they have the same base, you can add their exponents. Okay, are we doing pretty good?
Yes.
Okay. All right, good. All right, number 22. Now we're throwing an easy one in here. The coefficients are just 1. The bases are the same. They're both x. So what do we do with the 2 and the 5? Add them. So x to the 7th power. Very good. Sorry, that. Okay, number 23. What are we going to do first in 23? Multiply the coefficients, okay, which are
3
and 4. So 3 times 4 is 12. And then do we have bases that are the same?
Yes.
We have x squared and x to the 5th, so that's going to be x to the 7th power. Good. Okay, 24. The coefficient, 7 times -3. Negative 21. We have the same base, so we can add those x to the
12th power.
12th power. Very good.
Okay.
We starting to feel a little more comfortable with it?
Yes.
Okay, 25. Multiply the coefficients. -4 times 2.
-8.
-8. X to the 11th power. Very good. Now we're going to throw in some different variables here. Okay? Still multiply the coefficients first. 3 times -9. -27. Now, we have an x squared, and we have an x to the 11th. Those are the same base. So we're going to put x to the 13th power. Okay, sorry. So x to the 13th, and then y, you can add the y's. Y to the third. 1 plus 2 is 3. Okay? You guys follow that okay?
Yes.
So you can add the exponents of the x's together and the exponents of the y's together. Okay, so 27. Negative 4 times what? Negative 1 is positive 4. X to the 10. Y to the 17. Very good. Okay, and I'm going to see if I can do 28, then I'll scroll this up. Okay, so negative 8 times negative 7 is positive 56. Now we have an a to the third power, and we don't have any other a's. So what do you suggest that we do?
We just
keep it, a to the third power. And try to write your variables here in alphabetical order. Because with multiplication, order doesn't really matter, so we can make sure we put them in alphabetical order. That's how I like it. Okay? And then b to the first power and b to the fourth power, so that's going to be b to the fifth power. And then c to the sixth and c to the fourth is c to the 10. Okay, all you're doing is adding the exponents.
Then you just put them right after each other.
A, B, yep, all side by side because that means multiplication. Yes. No, we're going to do that in a couple days. Yep. Okay, so I'm going to erase this, then I'm going to move the paper up. Okay? Maybe. Oh, whoops, it did. Okay. All right. Now, on 29, is 3x squared the same as 3x in parentheses squared?
No.
Anybody want to tell me why?
It's the same answer.
Nicholas?
Because in parentheses you multiplying 3x times 3x, and then in regular you're multiplying 3 times x and then x times x.
So 3x squared is 3 times x times x, right? Which is really just this. But 3x squared is 3x times 3x, which you know now is what?
6x.
9x squared, right? Right? And so they're not the same, are they? 3x squared is not the same as 9x squared. See how the parentheses make a difference? Okay? All right, now we're going to go on to division rules. Okay? So when we're multiplying, if the bases are the same, we add the exponents. When we're dividing, if the bases are the same, we subtract the exponents. So that's your third rule for today. So somewhere on your paper, write down, when dividing with the same base, subtract the exponents. Okay, so here we're dividing 3 to the 8th power divided by 3 to the 5th power. Do we have the same base? The base is 3, so we have the same base. So we can write the base, which is 3, and then subtract the exponents. 8 minus 5 is 3. And so I would like to see that first, and then you can continue to evaluate. You can continue to simplify that down to 3 times 3 times 3, which is 27. Now let me just kind of put something over here that maybe might help make sense of that. So 3 to the 8th power means this. Right?
Yeah.
Would you agree that we know that a number divided by itself is just 1? So those can cancel and make 1. 1. 1. 1. So all of that is just 1. And you're left with 3 times 3 times 3, or 3 cubed, which is 27. But rather than writing that all out, which can be really ugly if the exponents were large, we have this rule now that says to subtract the exponents. Kind of like our shortcut. Okay? And you're welcome to write that down in your notes if you think that later looking back at that might help you. Wouldn't be a bad idea. Okay, whether the base is an integer or whether the base is a variable, you're going to do the same thing. So for 31, we have a variable here. The base is a variable. It's x. X to the 8th divided by x to the 5th. So the base is the same. It's just x. So we're going to write x, and 8 minus 5 is 3. Now, because we don't know what x is, that's as good as it gets. The answer is just x to the third power. Okay, who wants to help me with 32? Nicholas?
You divide 6 by 6 and then
Okay, don't do 6 divided by 6. That will mess you up. Okay, don't do that. You keep the base. See in 30 how we kept the 3? You keep the base.
6 squared.
Yes. A lot of kids want to divide that. Don't do that. Keep the base and subtract the exponent. Then you can continue on and write that as 36. Good. Okay, 33. Keep the base. X to the second power. Good. Okay, now, let's see what happens when we have coefficients here. Okay, so when we had coefficients with multiplication, we multiplied the coefficients first. Then we added exponents of like bases. With division, we're going to reduce or simplify the coefficients first. And then we'll subtract our exponents of like bases. So 6, I usually, as soon as I see a division problem, I do that. And that way, I already have my fraction set up. If everything I end up writing is on top in the numerator, then I can just erase my line. Okay, but that way it's set up. So 6 over 3 simplifies to what?
2.
2 over 1, right? Now, I told you that you subtract the exponents of like bases. So we have an x, that's the same base, and we have 4 minus 2. The question is, where do I put it? In the numerator or the denominator? You're going to put the variable wherever the larger exponent is. So in this case, the larger exponent is in the numerator. So the x goes in the numerator, and you still subtract. 4 minus 2 is 2. Now, because everything ended up over 1, we know that our rule, anything over 1 is always whatever was in the numerator. So that's done. Okay, let's look at 35. Simplify 6 over 30. 1 over 5. Okay, now we have x and x. We have a like base. Where's the larger exponent?
5.
In the numerator, so the x goes up here, and 8 minus 3 is
5.
5. Now, how could I write that so that that looks more simplified?
X equals 0.2.
x to the 5th power over 5.
We don't need the 1 in front of the x. We know it's there. We don't need to have it. X to the 5th over 5. That would also be the same thing if you wrote it this way. 1/5 x to the 5th. You could write it that way with the x to the 5th out to the side. That would be okay as well.
Why is the x over, and why is it in the numerator instead of the denominator?
Because you're going to put the variable wherever the larger exponent is, and the larger one is in the numerator. 8 is larger than 3. And we're going to see that now in 36. So 27 and 36, what can go into each of those? What's the largest number that can go into each of those? 9, yes. 9 goes into 27 3 times, and 9 goes into 36 4 times. Okay, look at the x. Now, one variable at a time. Now that we've got more than one. Where is the larger exponent? In the denominator. So the x is going to go in the denominator, and 8 minus 4 is 4. Since we know it's going to be in the denominator, now you start with that larger exponent. So you're not going to have any negative exponents here, because you're always going to take the larger minus the smaller. Okay? Now look at the y's. This is a 1. Where is the y going to go?
The top.
In the numerator, because 2 is bigger than 1. So y goes up here, and 2 minus 1 is 1, but we don't need to put a 1 for an exponent, because just like coefficients, if there's not a number there, we know it's 1. So with an exponent, if there's not an exponent, we know it's 1. Okay, look at 37. 16 and 28, what can go into each of those? 4. 4 goes into 16
4 times.
4 times, and 4 goes into 28 7 times. Looking at the x's, where's my x going to go? The numerator, very good. And 9 minus 3 is 6, good. Where will my y go? Good. And 8 minus 1 is 7. What about my z? In the numerator, and what's my exponent? 1, but we don't need to put it, right? Because 7 minus 6 is just 1. Very good. Now, 39 actually is the same as that one, so we're not going to have that. We got one more to do here. 18 over 9 simplifies to 2 over 1. Where does the x go? Numerator. What is the exponent? 2. 9 minus 7 is 2. What about the y's?
Cancel out.
Yes, they're just going to cancel. Y times y on top and y times y on the bottom will just cancel to make a 1. And so since it's all over 1, we can just rewrite this as
2x squared.
2x squared. Very good. Is this unit 5?
Yes.
Five.